Alright, in this problem we have a rock that is attached to a spring and is being swung in a circle in space. Alright, and the first thing that we want to find is the velocity. Alright, so we start off with our fundamental theorem, which is the momentum principle, that the force is equal to the change of momentum over the change of time. And we know that for things moving in a circle constantly like this, that it is equal to the magnitude of the velocity over the radius times the magnitude of the momentum. Alright, now the problem tells us that the force of the spring is equal to the net force. Alright, so force of the spring, and we'll make this magnitude is equal to V over R, and we're going to make this P into M V. Alright, now we want to solve for V, so we'll divide by M and multiply by R, so we'll have R S over M equals squared. So we take the square root, whoops, that's ugly V. So we'll take the square root of both sides and we get R okay, and then we just simply plug in the numbers, which are the radius is equal to 6.5, the force is 640 newtons, and it has 4 kilograms. Solve that and we get 32.2 meters over seconds. That is equal to the velocity. Alright, so that's how we solve for our velocity. Alright, the next part of the problem asks us to solve for the, hold on, I'm writing that down. Alright, the next part of the problem asks us to, let me read it so that I'm not miswording it. The direction of the spring force. Alright, and by looking at the problem, if I could scroll up, by looking at the problem, we're going to know that the direction of the spring force is going to have to be toward the center of mass, because it's moving in a circle, and whenever something's moving in a circle, the direction of the force has to be toward the middle, because that's, as it changes, the direction changes, and ultimately it'll be pointing toward the middle. Alright, so toward center of the circle. Okay, and lastly, we want to find what is K. What is the coefficient? What is the coefficient of the spring? Alright, so what is the stiffness of it? The stiffness of the spring. So we know that spring is equal to K times delta L. Well, in the problem it tells us that the relaxed length of the spring is 6.1 meters. So it's just simply 6.5 minus 6.1, and then K equals 640 newtons, and we get 0.4, so K equals 640 divided by 0.4. That gives us 1600 newtons over meters. And that's that.